It's a great pleasure for me to introduce Jürgen Bauhus. Jürgen, he's professor for silviculture at the Faculty of Environment and Natural Resources at Freiburg University in Germany. He's in this position since 2003. He has a long journey through science. He studied forestry in Freiburg, Wien, and Göttingen. He made his PhD in Göttingen. Then he made a postdoc in Quebec and also later on in Australia. When we talk about science, his research focus is on dynamics and management of structure and composition of forests, carbon and nutrient cycles, ecological interactions in mixed species forests, as well as the adaptation of forests to global change. That means, of course, he's very active in science, he's a highly cited researcher, but aside of this, he is very much engaged in networking, in scientific networking, but what is especially important also in the interface between science and society. Just to give you one example, there are many, many more. He is since 2009, he's member, and since 2020 is the chairman of the Scientific Advisory Board on Forest Policy at the German Federal Ministry for Food and Agriculture. There are many more, but I will stop here. Just one thing to add, I think just because it's very actual, very new, Jürgen Bauhus is the spokesperson for the Cluster of Excellent Future Forests, financed by the German Research Foundation. I think it was founded or decided a week or 2 weeks ago, so brand new. With its aim to develop, analyze, and evaluate transformation pathways towards resilient forests and resilient systems, their governance, management, and use. I think this is something extremely important, not only for Freiburg, but I think for the whole community. I think Freiburg will have a leading role in the next years, in the next coming years on these important topics, and there will be a lot of collaboration also within this context here. So I'm very much looking forward to this, but mainly for your presentation. Please, Jürgen, the floor is yours.
So this works. Perfect. Thank you very much for this very kind introduction, Andy, and also for the invitation for this keynote here. A keynote is always a special opportunity to develop a few thoughts on issues you usually don't think about in your everyday life, between desk and lectures and so on. I'd like to use that freedom to share a few thoughts on this topic here, integrated forest management, more of everything. And I don't really mean everything, but want to stick within the topic of this conference here, and that is biodiversity conservation and adaptation. And as you see, you have in your title, Close to Nature Forest Management. I will use a somewhat broader concept, integrated or integrative forest management, and I see Close to Nature Forest Management as one approach that fits under this umbrella of IFM. What I will be talking about is the following, a short reflection on this terminology, integrated or integrative forest management, because both is floating around frequently. I'll pick up this proposed definition that we have come up with in this Transform It EU project. And then the core will be on the discussion of the relationships between IFM and biodiversity and forest resilience and adaptive capacity. That will not be done without asking how integrated should IFM be and at what scale. Do we have to run out now? Or? Okay. Talk briefly about possible leakage effects and last but not least, address the question to what extent IFM can also be a useful concept when we want to view forests as socio-ecological systems that we aim to adapt to global change. So, integrative versus integrated. I personally actually prefer integrative. And when I suggested this title to Andy, I probably forgot about my preference. but so be it. The two terms are, of course, closely similar. I think integrative refers more to an approach rather than a condition, yeah, and more to an attempt rather than to something that has already been achieved. And looking at the times that we're in, where future is rather unpredictable and we will have to be continuously adapting our forests, I think integrative is in most situations probably a better term than integrated. Forests, at least here in Europe, are usually multifunctional, and managing these forests simultaneously for many of these functions is never an easy task, and it is becoming more complex with the unpredictable future, not only of the climate, but also of society's aspirations. And IFM is being viewed as a solution to that challenge, and it aims to harmonize all these different goals for which we manage forests, also with biodiversity conservation and adapting forests. And this is why we attempted to define it in our Transform It project, as is been written out here. So it's more than a short sentence, not surprisingly, when you try to cover all the different bases. So we defined it in Transform It as, or Integrative Forest Management aims at integrating biodiversity conservation and global change adaptation into forest management for the sustainable provision of multiple ecosystem services. It is guided by natural and diverse forest structures, compositions, and dynamics to support ecosystem functioning and resilience. Its management practices consistently consider the tree stand at landscape scale and employ different silvicultural intensities, including intentionally unmanaged forests. And IFM can be applied in any type of forest to achieve integrated environmental, economic, or social outcomes. So this definition has raised a few eyebrows, as it does now. And some responses that we received were particular regarding this contains intentionally unmanaged forests, because that is usually being seen more as a segregative approach. Also, that it should be considering the landscape, also raised a few eyebrows. But we deliberately put this into this concept because we believe only if we consider these two aspects can we truly speak about integrative forest management, and I hope to convince you of that argument. So coming back to the talk and to the title of this event here, the logic behind the title of this event is that obviously integrative forest management, which influences forest composition and forest structure in a certain way, promotes biodiversity from the levels of the genes to communities and ecosystems. And usually we mean native biodiversity with this. And this biodiversity is the basis for the resilience and adaptive capacity of forests and promotes that. But resilience and adaptive capacity are not a means or an end by itself, but are the basis for the future and sustainable provision of ecosystem services. And this logic is not new. And you can see it also being applied already in policies or funding schemes. In Germany, for example, we have this climate-adapted forest management, which follows this logic, where the adaptation of forests is being financed to ensure the provision of ecosystem services. And the criteria that forest owners have to fulfill are largely regarding biodiversity and adaptive capacity, but expressed in terms of forest structure and composition. The question is, of course, what's the evidence for that? As a scientist, we automatically ask whether there is a solid foundation for this logic. And that's also something that I would like to pick up in the next little while. However, I won't be looking at the functional relationships between, say, structure and biodiversity and adaptive capacity, because this is something that has been subject to many scientific reviews. Just showing one here that appeared recently, which we produced with a large collective of authors, as you see here, where we looked at basically statements and approaches that are being used by forest management agencies, state forests, and so on, where they say, if you want to adapt your forest, this is what you have to do. And we looked at the scientific evidence, and it's well described there. And we have similar reviews for the relationship between forest structure, composition, and biodiversity. I want to basically use a somewhat simpler approach to look at the evidence by asking, what evidence do we have that the management of forests using an IFM approach actually leads to increased biodiversity and leads to a greater adaptive capacity. And the way I will do that, I will explain in a moment. Starting with biodiversity, we have here from Kurt Bollmann and colleagues this very nice approach, which is called a unifying framework for the conservation of biodiversity in multifunctional European forests, where he, I think I better use this laser pointer, then I don't get a stiff neck turning around here, where he looked at which conservation instruments, as he calls them, at different scales, from large-scale instruments to intermediate to small-scale instruments, serve which processes and attributes that are important for the conservation of biodiversity. And these can be ranked basically along a gradient of increasing integration and decreasing segregation. And we'll come back to that. I want to use the case of the German NFI to ask that question, if we manage forests with an IFM concept, what do we actually achieve? And I'm not saying that every forest in Germany is being managed by IFM, but considering that probably more than 90% of the forests are certified, either by FSC and PEFC, and we have also a large share of public forests, we could say that a large proportion follows a certain type of IFM approach. It also means that the results that we see are probably a conservative assessment of what can be achieved. It would, of course, be much better to compare IFM enterprises with non-IFM or conventional forest enterprises. That's what we're doing in Transform It. But we don't have the results yet. That will be a more robust assessment. And so when we look at changes of biodiversity relevant indicators for this most recent NFI period, 2012 to 2022, the results have only been published last October, we see actually quite significant changes. We see an increase in the proportion of mixed forests, increase in the proportion of deciduous forests, increase in vertical structure, the number of old and big trees, the amount of dead wood, naturalness of tree species composition. We see also that the percentage area with an excellent conservation status, so in Natura 2000 reserves, increased for the most widely distributed Natura 2000 habitat types, beech and conifer and beech mixed forests. We have at the moment roughly 6% of forests that are not managed, and a bit more than 3% qualify as what we call forests under natural development that are also legally protected. So a number that is still way behind the targets of, say, 5% that we currently have. We have a stable number of trees per hectare with special characteristics. You could call that microhabitats. And we see also some somewhat concerning developments, not very strong, but increase in neophytic plants and an increase in some introduced tree species in the regeneration layer mostly, and that's mostly black cherry. If we have a closer look at some of these changes, for example, in deadwood, we can observe that we had an almost 50% increase in deadwood within a 10-year period. That's, of course, to a great deal attributable to the massive disturbances that we had. And an increase basically in all types, mostly in standing deadwood, not surprisingly, in all diameter classes, as you see in this figure here. And in addition to the disturbances, the result will also be attributable to specific programs for old and deadwood. The problem is that we cannot say to what extent these specific programs have actually contributed to it, which is rather unfortunate because we cannot really evaluate the efficiency of these policies. We look at old and deciduous forests. We see a tremendous increase of 22% of large trees, greater than 50 centimeters dBH. A remarkable increase in forest age. When you look at these three age classes here in this figure, from 120 to 140 to those over 160. Those older than 160 increased by 44%, which is obviously not a result of some random processes like disturbances, but very conscious management decisions. And even if that decision is simply, I won't touch my forest anymore, but a tremendous increase in old forests and an increase, substantial one, in the area of deciduous forests. So what we see is that obviously, when we look at these integrative elements, we are quite successful in changing structure and composition in a very short time, 10 years, quite considerably. Or the forests are changing. As I said, it's difficult to say how much this is being done by intentional management in some parts and how much by natural processes. And that is a deficiency that we have in our monitoring systems. But what we see as well is that these very integrated elements are relevant, mostly relevant for a number only of these processes and attributes. And there are a number of processes and attributes that we don't achieve by these more integrative elements. And we have little information, at least from the National Forest Inventory, on success, say, in natural disturbances or stand mosaic cycles and more landscape scale properties or larger scale properties. And this is where this very interesting publication that came out last year by colleagues from Göttingen is, I think, providing a good insight. It reviewed the influence of structural heterogeneity and high multi-taxon biodiversity in managed forest systems and its drivers. And this study basically came up with some, what I think, very important findings. And one is that both the research as well as the management guidelines that are derived from it have a strong focus on stand-level heterogeneity and the related alpha diversity, and that the importance of the beta diversity, the within patch or within stand diversity, and the landscape diversity are often not sufficiently acknowledged. And we'll see examples for that. And the indicators that are being used to evaluate forest diversity do often not reflect multi-taxon diversity, but they look at birds only, or lichens or ground vegetation. So we're not really able to say to what extent certain measures really benefit or suit the whole of biodiversity. And they come to the conclusion that, which is not surprising, an all-in-one inclusive system to manage forests for sustainable wood supply and simultaneously promote biodiversity does not exist, and suggests that combinations of different biodiversity-friendly management systems seem to be the best approach to increase stand and landscape scale heterogeneity. This work was probably triggered by a study that this group published earlier, where they compared even-aged with uneven-aged forests, beech forests. And you see one figure from this study from 2017 here. For one, you see that they really looked at multi-taxon diversity, looking at all sorts of different taxonomic groups and not just the species with feathers and fur and so on, but also the ones that are often more obscure. And what you see here in this figure are the number of exclusive species that you have only in one system, like the even-aged or uneven-aged. Even-aged is the cyan blue, and uneven-aged the yellow. And you see that where we have significant differences, these exclusive species that occur only in that system are always belonging to the even-aged, which is simply providing more habitat heterogeneity that supports this system, these species that are not in the other. And that is one of the causes for the higher landscape level diversity in these even-aged systems. They basically suggest that to maintain biodiversity, we should employ really the whole suite of different forest management systems, basically in terms of both vertical heterogeneity, which reaches here from even-aged or mono-layered stands to really multi-layered uneven-aged stands, and horizontal heterogeneity, which is the grain size at the landscape scale from small gaps to large open areas. And they've basically penciled in here different, basically silvicultural systems that achieve that and that are suited to promote, for example, at this end, more shade-tolerant species, and at this end, more light-demanding species. One could say that the traditional, closer to nature forest management approaches sit in that corner, and that only points to perhaps some of the shortcomings one might imagine where we don't have that landscape scale heterogeneity. However, I would say that some of these deficits in recent years have certainly been overcome by a lot of disturbances that have occurred basically in most of our landscapes here in Central Europe that provide for this more open and structured situations. The question that is being thrown up with this diagram is, of course, at what scale do we integrate? Yeah? And it's been discussed, certainly among ecologists, and I think there's much consensus that for sustainable forest management, we ought to have a certain or different pillars. The triad system is one sort of element of this discussion, which says that we need to have 3 systems of different management intensities. You ought to have some strict reserves, which support certain species that may otherwise not exist. We ought to have also relatively intensively managed forests to provide us with the timber that we need, and we need close to nature forests, or call them something else, ecoforestry or continuous cover forestry, which are basically the matrix in which these other elements that typically comprise only a relatively small proportion of the landscape are embedded in. And the wedges that you see here from this publication from Larsen et al. That Frank already alluded to are probably not drawn to scale, because the natural forest, the strict reserves, at a global level, they make up about 12% or so of the forest area, and these intensively managed forests, they make up 5-6% of the forest area. So this matrix in the center is much more important. The logic behind this triad system is that you can basically move a lever, yeah, across these different systems. So if you want to increase natural forests and move this lever to the left, it would mean that to compensate that within the landscape, you would automatically also increase the area of intensively managed forests at the expense of the matrix, the closer to nature managed forests. What we see at the moment, as far as I observe that, at the European level and perhaps also in other countries, is yes, we are moving towards more natural forests, because particularly in Europe, we also have a great deficit. We have very few percent. Gert-Jan would know that, probably less than 4 or 5% of strictly reserved forests in Europe. At the same time, we are expanding or trying to expand the area of close to nature forest management, which is meant to become the paradigm of reserve forests in Europe. And at the same time, we're trying to decrease the area of more plantation-like forests to increase the area of close to nature forest management. And so these things do not really go together, and they already point at the problem that if you follow this approach, you will inevitably produce leakage effects. We'll not go into this further, something that can be picked up in the discussion. That's why in this publication by Larsen et al., we depicted the approach that we should use in integrative forest management, something like that, where close to nature forests are the multiple use forest matrix in which forest management takes place. And then within this matrix, we have strict forest reserves of different size. We have old growth stands or patches of early successional forests, and within the matrix also a dedicated reservation of structures, deadwood, habitat tree groups, and so on, that facilitate the movement of species of different mobility. But as you can see, this landscape also contains intensively managed forests to ensure that we solve the problems at home. The question is, of course, how large is this landscape that we're looking at here? And this addresses an issue that is certainly somewhat difficult in parts of Europe, where we have, as you can see here, countries with very high proportions of privately owned forests, many of which are very small, and where we have usually very little coordination of management goals and activities. So how do you get these landscapes that support these kind of combinations? And it's obvious that the public forest plays an important role here, because the public forest needs to, in many situations, compensate what is happening in private forests if there's no coordination among private forest owners. Before we move on to the question of adaptation, one thing that we should remember when we talk about biodiversity in European forests is that what we do in forests actually affects only, or has only certain effects on what we actually see in biodiversity happening in the forest. And that's what you see here, where through forest management we may change species composition or site preparation, etc. And we have certain influences on structure or certain species groups, but climate change, biological invasion, land use changes, pollution, for example, through agrochemicals, all plays an important role. And at the moment, we cannot really distinguish between these. Coming to the question, to what extent does IFM promote or impede forest adaptation to global change? I like this depiction here of colleagues Putman and Messier on what we're trying to achieve with forest adaptation. Say, if this is our current condition here, which is characterized by a certain species composition and stand structure, and this gray, pale gray area are possible combinations of structure and composition. But we have certain forest compositions and structures that provide us with the desired ecosystem services in future. So that's the dark gray. So what we should try to achieve is to develop multiple options for the future conditions of the forest that we aim to obtain. And that can be done through promotion of functional diversity, of ecosystem components, promotion of interactions within and between hierarchical levels, and promotion of self-organization of ecosystems. And let's have a look again at our example here from the National Forest Inventory. We're lacking some information. For example, we don't have information on what proportion of the forest is covered by species that are unsuitable at that site for future conditions. We know that it's not small. It's more than 30%. We're looking only at spruce and beech forests in Germany. So again, we have, to some extent, more indirect indicators for resilience and adaptive capacity. What you see here is a relationship between the proportion of mixed stands and the proportion of multi-layered stands for different species groups from 2002 to 2022. And again, we see very favorable developments in a relatively short period of time. So, pine forests and spruce forests, which predominate our forests, becoming more diverse and more structured. To a lesser extent, we see that in oak, and we don't see this sort of continuing mixing in beech. We actually see lately an opposite trend in beech forests, which are largely managed as natural forests. So more deciduous and mixed forests. We see, of course, also a decrease as a result of these changes of vulnerable stands. And that decrease in vulnerable stands is also a result of the disturbances. But we have large regional heterogeneity in southern Germany Baden-Württemberg and Bavaria, we still have a large increase in vulnerable stands. Yeah? So the growing stock in spruce forests, for example, is still increasing there. When we look at another component of resilience and adaptive capacity, namely advanced and natural regeneration, we see things that some years ago we would have said are really wonderful developments, which, facing climate change, global change, raise concerns now. What we do see is that advanced regeneration, which is very important for the resilience when the main stand, for example, is wind-thrown or affected by drought, is providing already the new forest that can start readily. That advanced regeneration covers 1/4 of the area. But when we look more closely, we see that, and you see this here in this right figure, 50% of the regeneration in spruce forest is spruce. Yeah? So there will be a large proportion of future stands where spruce is also not suited anymore. Conversely, we see in oak types, which oaks are species that we want to promote for the future, that only 13% of the advanced growth there actually consists of oak. Yeah? Most of the regeneration is running towards more shade-adapted species. And you see this also here for beech forests, where we have more than 70% of the regeneration dominated by beech. So we have a high proportion of natural regeneration. Most forests have more than 90%, or more, in most species, we have more than 90% of natural regeneration, and little change in the problem of browsing by wildlife. And so we see that there is a risk of maladaptation through regeneration. And this message is basically reinforced by findings from this group from BFW, Dev Chakraborty and Silvio Schüler, who looked at the potential for assisted migration to maintain the carbon sequestration potential of European forests. And in their study on the impact of assisted migration on the carbon sink, they looked at 7 most important species in Europe and looked at changes in the carbon uptake of plots basically dominated by these species for a past reference period and then future scenarios under RCP 4.5 and 8.5. And we see that if we only use local provenances of these species, we see a strong decline. And we see that basically when we use adapted species, and the information for these adapted species are coming from provenance trials across Europe, that there's a great potential to have more productive forests. And the study here basically also comes to the conclusion that it would be wise to avoid these adaptation deficits that we see. We see here in this figure basically that already now local populations are not the best adapted compared to provenances from further away. And they say that we need flexible support for regeneration of site-adapted tree species, no primacy of natural regeneration over other forms of regeneration, and European perspective regarding the identification of suitable species and provenances. So, looking at the time, I need to speed up a bit. So, regarding the question, what's the evidence? I think that the logic that we put forward is not as easy as we assumed at the beginning. We do have both positive, but also to some extent negative consequences of IFM on biodiversity. but we also have influences of IFM that go directly to the resilience and adaptive capacity, not necessarily via changes in biodiversity. Coming back to this, the study that I mentioned by colleagues from Göttingen, they compared the development of these integrative concepts over time, short period of time, from 2015, from this publication, to 2022, to this publication, and it shows some elements that have been added since then, and that is the retention of habitat trees, special habitats and deadwood, the promotion of native species as well as site-adapted non-native species, and supporting the landscape heterogeneity and functioning. And I hope that the examples that I showed you clearly indicate how necessary these additions to the definition or the development of the concept of integrative forest management have been. Coming to the conclusions, I think that we see that integrative forest management appears to be quite successful in promoting biodiversity-friendly forest structures and compositions at small scales, that the achievement of landscape-level conservation measures and habitat heterogeneity is obviously more difficult in a European context, so the landscape level, and this is where we need more progress. Many IFM principles support the adaptation to global change, such as more structurally diverse, species-diverse forests, but some of them may also lead to maladaptation, things that we thought were good in the past, and here some adjustment is necessary. And IFM certainly requires combinations of both integrative and segregative conservation and production approaches to achieve the objectives and to avoid unintended leakage effects. So I'll jump over this and finish with this slide. The question, to what extent can IFM help us to maintain resilient and socio-ecological systems? So in future, we will see novel socio-ecological systems. Novel because they're subject to stark environmental changes, but also strong societal changes. And these systems that we want, these resilient socio-ecological systems, occur only at this overlap between the capacity of the ecosystem and that what society wants for itself and for future generations. And changes to this system can be brought about by, for example, here, changes to biotic structures and assemblages through introduction of non-native species, but also through changes in societal values that feed back through this novelty cascade that you see there. And so I think that the potential of IFM to achieve this resilient socio-ecological system lies really in two things. In one, creating many options, here on this side, for the capacity of the ecosystem, to cater for the unforeseeable demands of society and maintain functionality also for these changing demands. But I think the other strength of IFM also lies in the fact that we need, particularly when we look at the local scale, where we try to integrate the different objectives, this forces or encourages us to actually negotiate the outcomes of forest management. And IFM relies on that, but it also provides a good platform for that. So these resilient systems are, of course, subject to the risks, to adaptation, but also through transformation. And only transformation, I think, will allow us to keep that overlap between these two spheres really large. And that's why in integrated forest management, I think we have to think in future more about transformation rather than only adaptation. And with that, I'd like to thank you for your attention and apologies for perhaps going over time.
Thank you very much, Jürgen, for this wonderful presentation. I'm sure there are questions. We have 5 minutes for the questions before the next keynote. Who has a question, please?
Sorry, somebody has to be you first. And okay, Jan Liera from Estonia, University of Tartu. I don't see in your presentation about integrative forestry, about environmental heterogeneity, what is already beneath the trees. So like soil heterogeneity, the relief, the moisture levels. And this will drive most of your integration.
I think that if I understood your question correctly, a lot of the variability also at the landscape scale is of course driven by also environmental features. And these need to be taken into account or made use of to maintain that heterogeneity that comes, for example, from soil conditions, etc. Yeah? So geodiversity translates into biodiversity, and we should maintain that and not ignore it and, for example, plaster spruce across these different site conditions. So I think it's a question of recognizing that diversity and considering it when shaping and maintaining landscape level diversity. I hope that addressed your question.
Okay, thank you. Thank you for the fantastic presentation. My name is Vera Steinberg. I work for the Federal Ministry of Food and Agriculture in Germany. And my question would be if there's any attempt to find, let's say, the perfect percentage of the 3 management types between the integration, segregation, and set-aside matrix. So to kind of give recommendations of how many percentage of forest you really have to set aside or you really can use for wood consumption, maybe on country level. I think for Europe that would be a bit too much, but to give more guidance on how the future of the forest should look like.
So I'm not tempted to give a quantitative answer, because I think that these figures are, of course, subject to negotiation. It has to do a lot with values that society places also on that. But globally, we don't need much really intensively managed forests to feed the world with wood and fiber. Yeah, there are some calculations that say basically 6 to 7% of intensively managed plantations globally are enough to provide us with the wood that we need. And that, of course, is so because the global background level of production is relatively low. And when you look then at increasing that through intensive plantations, you can save a lot of area. Say in a country like Germany, we are managing our forests already quite intensive. So the potential to raise that, say through more intensive management, is actually relatively low. But this can be calculated. Yeah? And in terms of, say, strict reserves, I think we should try and achieve, first of all, the figures that we have been wanting to achieve, and we're still struggling to achieve these 5% of strictly protected forests. And then I think it is also wise to have a look at the effects of that. We're launching programs, for example, these old and deadwood concepts and so on, and we're still not able to say what have they really achieved. And I think before we move on to the next target and the next target, we should actually have a good look at what have these programs achieved.
Okay, we have time for 2 more questions, please.
Thanks, Jürgen, for that great talk, providing this very broad picture. I have a more targeted question, because it's normal that everybody poses a primate that high biodiversity increases resilience. We, however, know, and that might be related to kind of optimizing the niche space, that under particular conditions where drought or water availability is normally not limiting, tree diversity increases the above ground niche resource space, and that might provide also kind of maladaptation, so that if a drought hits, resilience is lower. That happens often in boreal forests, but partially also in temperate forests. Is that something we have to take better into account in such a picture, and maybe kind of not always saying biodiversity is always good for resilience towards climate factors in that case mainly? Or is it something which might be also politically dangerous, because we have in the last years and decades always told everybody to diversify the species composition?
Well, I think when you look at the publications that are coming out, we see that the story is not that easy. Yeah, we have also neutral and also negative effects of diversity. One of my PhD students is currently working on a paper that shows that at a small grain, when you look at individual tree species, increasing diversity may actually have a negative effect on mortality. Or supporting, promoting mortality. And so I think we need to be mindful certainly of the scale at which we discuss that. Yeah, sort of at a small grain, yeah, diversity can lead to more stress, more competition. But at a larger scale, diversity certainly leads to a risk spreading. We need to differentiate between these two. And for the former, we need to look at the mechanisms and see which species can we best combine to avoid the negative and benefit from the positive processes.
One very last, I hope so, please.
Anders Esslin, Sweden. Can you elaborate a bit more on adaptation and transformation? I mean, most people can accept a bit of adaptation. Transformation scares the hell out of people. So could you just give us a short elaboration on that?
Mm-hmm. Yeah, that's it is. So I think when we talk about adaptation, and this is what I was trying to show with the last slide, we're not just talking about adaptation of forests, also as a society, we have to adapt. And we have to also transform, I think, in terms of how we view forests and what we want from forests and what changes we are willing to accept from forests. This is a slide that I skipped. It's from a survey that we did in another EU project, Resonate, where we looked at the perceived effectiveness of adaptation measures and the level of application on the y-axis of these adaptation measures. And the darker and the bluer, the more responses there were. And you see some of these silvicultural adaptation measures here. So mixing, Arthur, features here, where people perceive that as very important and it's being applied by everyone. But when you look at introducing new tree species, the majority is thinking that is moderately to highly effective, but the application is very low because the strongest impediments are regulatory difficulties and the anticipated social resistance to it. And this is a challenge. It's also a challenge that we need to address in integrative forest management, because a lot of the rules that are giving us in Europe that we see also in certification schemes are based on our classical IFM thinking, that with natural species, natural regeneration, we will wonderfully grow the most resistant and resilient forests. And we simply have to do away with that idea.
Thank you very much. Unfortunately, we have to stop here. So please give a hand again to Jürgen Bauhus.